in this video, I'm going to show you how to simplify these radicals that are not perfect squares. Since they're not perfect squares, that does not mean I can't simplify them. For example, if I have the square root of 16, that's a perfect square. I can easily say that is 4. But when I have the square root of 12, I don't have a number which I multiply by itself and get 12. Okay? So this is not a perfect square. I'm going to show you two techniques on how to simplify these kinds of radicals that are not perfect squares, but I can simplify them a little bit. I'm going to show you prime factorization first, and then we're going to do it using a different method using the product property. Let's do prime factorization. Prime factorization means you take a number and you factor it all the way down, break it down into factors, all the way down to having only prime factors. So I have number 12 here, and I'm going to create sort of a tree, and I'm going to break 12 up into two factors. I can break it up into 4 times 3 because 4 times 3 is 12. I could do 6 times 2 because 6 times 2 is 12. It's your choice. It doesn't matter. You're going to get to the same place. I'm going to choose 4 times 3. 3 is a prime number, so this doesn't break up anymore. 4 is not a prime number. I can break it up further. I can rewrite 4 as 2 times 2. And that way I have replaced 4 with its factors, 2 and 2. 2 is also a prime number, so I'm done. I can't break 2 up any further. So here are my prime factors. 12 is the same thing as 2 times 2 times 3. Okay? So now here's my next step. Any pair of numbers that I get when I'm done doing prime factorization, every pair of numbers, that means one of those factors comes out of the radical. So I have a pair of 2's. That means that 1, 2 comes out of the radical. There it is, outside the radical. Anything else that is not in a pair stays inside the radical. 3 is not in a pair, so 3 stays inside the radical. So the square root of 12 is equal to 2 times the square root of 3. And we have simplified it. Let's do that with 24. 24, I'm going to prime factor it. So I'm going to break 24 up. You can do anything you want. You could do 3 and 8, 4 and 6, 12 and 2. I'm going to do 3 and 8. 3 times 8. 3 is a prime number. I can't break it up anymore. I can break up 8. I could do 4 times 2, and that means I don't have 8 anymore. Now 8 is represented by 4 times 2. 2 is a prime number, so I can't break it up anymore. And 4 I can break up into 2 times 2. So now I don't have 4 anymore. It's been replaced with 2 times 2. So I'm left with 3 times 2 times 2 times 2, which equals 24. Now what I do is I pair up numbers that are the same, and I see that I can only pair up these 2's. So for every pair, one of the numbers comes out of the radical. That means 2 is outside the radical. And then inside the radical, I'm left with 3 and 2, which is 3 times 2. We multiply them, and that gives you 6. So the square root of 24 is the same thing as 2 square root of 6. Let's do 50. For 50, I'm going to take 50, and I'm going to break it up. You can break it up into 2 times 25 or 5 times 10. I'm going to do 2 times 25. And then I'm going to do, since this is a prime number, I can't break it up anymore, 25, I'm going to do 5 times 5. 5 is a prime number. I can't break it up anymore, so I'm done. Now I create pairs. Here's a pair of 5's. That means one of the 5's will come out of the radical. And what's not in a pair, which is the 2, remember this 25, we've reused and rewrote it as 5 times 5, so it's not available. What's not in a pair, you leave inside the radical. So the square root of 50 is equal to 5 square roots of 2. Okay? I'm going to leave these answers up here, and now I am going to show you the other method of simplifying the square roots, and we will compare answers. And now I'm going to show you the second method, which is breaking the radicand up into factors. So here's what that looks like. The square root of 12, I can rewrite it using the product property. I can rewrite the square root of 12 as the square root of 4 times 3. Now that I have a product inside of the radical, the product property allows me to write the factors in their own separate radicals. And then I can simplify. The square root of 4, that equals 2. And the square root of 3 is not a perfect square, so I leave it inside the radical. Notice how I get the same answer as I got with prime factorization. Let's try the square root of 24. I can break up the square root of 24 into the square root of 2 factors. I can use 4 times 6. Notice how I always try to break it into 2 factors where one of them is a perfect square. So that's why I didn't use 2 times 12, because 2 is not a perfect square, neither is 12. I also didn't use 3 times 8, because 3 is not a perfect square and 8 isn't either. So I always try to look, when I break a number up into 2 factors, I always try for one of the factors to be a perfect square, because then I use the product property, which allows me to separate these factors into their own radicals, and then I can simplify. Square root of 4 is 2. Square root of 6, not a perfect square, so I leave it inside the radical, and notice how I got the same answer as I did when I did prime factorization. And now let's do the square root of 50. The square root of 50 I can rewrite as the square root. I'm not going to use 10 times 5 because 10 is not a perfect square and neither is 5. So I'm going to use 25 times 2 because I know 25 is a perfect square. And when I use my product property and I separate these factors into their own radical, I'm able to simplify. The square root of 25 is 5, and the square root of 2, since it's not a perfect square, I keep, and notice how I get the same exact thing. Okay? So now I want you to practice. I want you to choose one of the 2 methods shown on this video. You can go back, hit rewind, check both methods. Whichever you like the most, I want you to simplify. The square root of 18, the square root of 75, and the square root of 48. Hit pause, try them on your own, and I'll show you the answer in a bit. Here's the answer. I hope you got them correct. I'll see you in the next video.